in the practice. Okay. Hello and good afternoon, everyone. I think we can slowly start where people are still joining. Yes, welcome to this webinar of today. I'm very happy that we organized this webinar, which is R5 CMCC and Navigate co-organized webinar. And today we are very happy to have three excellent speakers on a topic that's, I think, very relevant: the climate transition, Central and Eastern Europe, insights from national and global integrated assessment models, and regional downscaling. So we're going to look at integrated assessment models, the climate transition, with a focus on Eastern and Central Europe, and some country case studies, which I think, many IAM studies look at the global results, including in projects such as Navigate, which is co-organizing this webinar. So it's great to look also a bit more at the country level in terms of policies and also in terms of the climate transition in general. So my name is Johannes Emmerling. I'm a senior scientist at the EIEE in Milan, and we're organizing this project together with Navigate, which is actually coming to an end by the end of this year, which has been or is a European Horizon 2020 funded project on developing the new generation or improving IAMs with application to a wide range of questions from global scenarios, but also distributional issues, structural change, the different sectoral challenges. So there was a lot of model development going on in this project, has led to a large number of publications and contributions to the policy process. And so we're very happy to have this webinar today. And we will have the three speakers in order: Fabio Sferra from IIASA, Maciej Bukowski from WiseEuropa, and Evelina Trutnevyte. Sorry for that, it's always hard, from the University of Geneva. We're going to start by the presentation by Fabio, who has been working a lot in the NGFS scenarios, which have been very much picked up in the financial sector, including and working on downscaling results to the national level, at which level, in fact, in the end, a lot of policy action happens. So the idea is to give like 12 to 15 minutes to each speaker, and then we have time around 3:40 Central European time. We have time for questions and from the audience and response from the speakers. Okay, with that, Fabio, the floor is yours, and if you can share your screen. I hope it works, and I will give you a heads up, 2 minutes, the last 2 minutes.
Perfect. Thank you, Johannes. I hope you can see my screen.
Yes.
Not yet in presentation mode. Now should be in presentation mode.
Yes.
Perfect. Yeah. Thank you. So basically, my name is Fabio Sferra. I work at IIASA, and today I would like to give you an overview of downscaling integrated assessment model results to the country level. Basically, the main motivation for developing a new downscaling tool is that integrated assessment models are used in order to evaluate the transition towards the Paris Agreement and get insights on how to decarbonize the economy. However, the regional resolution of integrated assessment models is limited to a few regions. And in the past few years, in particular under the Navigate project, the modeling teams have done a lot of work in order to make the regional resolution more flexible. And in particular, for example, models like Which or Message or Remind can now run with a flexible regional configuration, which is really great, so that the user can decide which regions should be in the model. However, it is still difficult to essentially provide results for all the countries in the world. And therefore, because of that, we have developed a downscaling tool at the country level. And then also WiseEuropa in parallel has developed a new downscaling algorithm focusing on the subnational level. And I think after my presentation, Maciej will give you a little bit more insights on how to decarbonize the coal-intensive regions of Poland. But in this presentation, I would like to focus more on a downscaling tool at the country level. The downscaling tool focuses pretty much on the energy variables, and then we also calculate the energy-related carbon emissions. Just starting with just to give you a little bit of an idea of how the downscaling tool works. Basically, we use the data that are coming directly from the model. We have the regional IAM results, and then we complement this information with the GDP and population projections that we get from the SSP database. And the nice thing about the SSP database is that it is really comprehensive. It has essentially all the countries in the world, and it also has projections for different storylines. We use this information to derive what we call the long-term benchmarks. So basically to get an idea of how countries should develop in the very long term, because our integrated assessment models are really good in providing the trajectories in the long term. Then on the other hand, in the short term, we try to use as much as possible the historical data that we get from the International Energy Agency. And really, in the short term, we try to replicate what's happening at the country level. And then as time goes by, we use more and more the information that is coming from the long-term benchmarks, and we call this approach conditional convergence. And the convergence is also depending on the level of economic development. Another nice feature of the downscaling tool is that we include targets in 2030 and 2050 at the country level, so that we can really make the results a little bit more realistic and really try to mimic what's happening at the country level, also in terms of the policies. And finally, we get the national pathways at the country level. In terms of the variables, as I mentioned before, this is pretty much focused on the energy sector. So we start by downscaling total final energy, and then also the breakdown by energy carrier, electricity, liquids, solids, gases, and the different sector, buildings, industry, transportation. Then we downscale secondary energy, and for example, for electricity, we also downscale the electricity mix. Then we calculate the primary energy by applying some efficiency factors from secondary to primary. And when calculating primary energy, we also distinguish between CCS and non-CCS technologies. And this is particularly important in order to calculate negative emission from biomass with CCS. Something that is relatively new that we have developed in the past few months is that now we are also able to downscale non-CO2 emissions and land use emissions. So now we are also able to calculate the total greenhouse gas emissions at the country level. Now, I just would like to jump into the results. As mentioned before by Johannes, basically the main tool has been applied in the Navigate project, but then the application of the tool so far has been mainly done under the NGFS project. NGFS is a consortium where also the central banks are involved, and also the modeling teams like Maciej, GCAM, and Remind. If you take a look at the website that you can see here in the link below, you can actually download all the downscaled results for all the countries. We have 184 countries downscaled that are in line with 6 scenarios. So basically the scenarios that we get from NGFS are current policies, NDC, which basically refer to what we call the hot house world. So basically very far away from the Paris Agreement. Then we have a couple of additional scenarios, which are disorderly transition scenario, where essentially countries will converge to the 1.5 or 2 degree in a disorderly way. So every country will have different policies and different targets. And then finally, we have an orderly transition to the below 2 degree and to the 1.5 net zero targets. I would like to give you an overview of the results by focusing in particular on Poland. So basically in this graph, you can see the greenhouse gas emissions in Poland under the different scenarios, and those are downscaled from 3 models, Maciej, GCAM, and Remind. And then, yeah, you can see the data from 2010 to 2050. Under the current policy scenario, the emissions in Poland will remain relatively high, between 200 and 300 megatons CO2 in 2050. If we look into the NDC scenario, then emission will decline a little bit more. And then if you look into the 2-degree or the 1.5 pathways, you can notice that greenhouse gas emissions are going towards net zero and even below zero in the 1.5 pathway. The graph that you can see here, the greenhouse gas emissions in Poland, it is something that it is not yet available in the NGFS results, but in the NGFS data portal. But we are planning to make a release in the coming weeks so that you will also get basically the data that I'm showing you today. So basically there will be a new release in the next couple of weeks where we will also add the greenhouse gas emissions at the country level. Yeah, and also then we can compare the total GHG emissions with the NDC targets in 2030, and the mid-century strategies in 2050. Just to give you also an idea on how to decarbonize the economy, basically, we have here the 3 models: Message, GCAM, and Remind. Starting with the orderly 2-degree pathway, you can see that coal needs to be phased out. Message and Remind envision a faster phase out of coal, which basically needs to phase out by 2030. And then according to GCAM, coal will remain a little bit more for longer in the energy mix. Then if we look in the 1.5 pathway, the coal phase out needs to happen even a little bit earlier as well, with basically even faster decarbonization. And then again, if we look at the GCAM model, the decarbonization will be a little bit more gradual, but this is also due to the fact that there will be additional BECCS. So essentially, if you notice here in the GCAM model, there's a lot of biomass, which is increasing in 2050, and there will be 100 megatons CO2 captured by biomass with CCS. So if we want to avoid reliance on negative emission technologies, we will need to aim for a faster coal phase out and faster decarbonization. If we look into the electricity mix, again, you can get even a better idea on the role of renewable energy. You can see that coal will be essentially replaced by wind, which is the blue area, but also solar. And then also, depending on the model, for example, Message, there will be also some nuclear technologies coming online after 2030. Then, if we look into the final energy demand, we can have a look into the industrial sector. You can see that coal, it is also used pretty much in the industry. And then if we basically look in particular into the 1.5 pathway, the use of solids will need to decline in the industrial sector by enhancing electrification. And there will be also some hydrogen that is coming in the energy mix around 2050. Then coal, it is also used in the building sector, in particular for the heating system. Again, here, all the models agree that essentially coal needs to decline over time if we want to achieve the 2-degree or the 1.5 pathway. And this can be done by essentially investing in district heating or electrification, and also retrofitting of the existing buildings in order to reduce the energy consumption for heating. Then jumping into the conclusions, basically, we have shown the greenhouse gas emissions in Poland under the 2-degree and 1.5 pathway, and essentially emissions should approach net zero by 2050 and even go below zero under the 1.5 pathways. Coal needs to be phased out in 2030 in order to avoid too much reliance on negative emission technologies, but that also depends on the models. And basically, that also depends a little bit on the model assumptions. And then coal phase-out policies should be also linked to scaling up of renewable energy. And the key sectors to decarbonize are essentially electricity, because this will pave the way for additional electrification using clean energy system, and also reducing coal consumption in the buildings and industrial sectors. So that's it from my side. Thank you.
Yeah, thanks. Great introduction from the global picture towards the national application here. So thanks a lot, Fabio, and thanks a lot for the application to the regional context here of Poland, etc. So, and the perfect also lead over through the work by WiseEuropa, which have also been a part in the Navigate project, and have several modeling tools actually with a focus on Poland, but also Europe, including subnational modeling. So very happy that Maciej found time to give a talk today. Yes, to look at the case of Poland using the MEMA model. So we can see your screen, so that's great. So Maciej,
that's right. So let me start. As you see, subnational level downscaling to the regional level. So basically, let's say following this structure that was presented already by Fabio, when we start from simulation that are done on the global level, and sometimes they cover some countries, sometimes they're not. And if they're not, you have to downscale to the country level, which has been presented how to do this. And then there's a problem of even further downscaling, which might be useful, especially from the policy perspective, as many policymakers are actually asking how it will impact their region, yes, how it will impact some very energy intensive or coal intensive region, and will it be good for GDP, for employment, what is going to happen in very particular case of a given region. Although, of course, there are also challenges with data, with granularity of data on the regional level, which is much harder than on the national level, because you can have a given an electric plant in a given region or don't have it, yes, especially if those regions are too small. So it depends on the country whether it is feasible or not, or easy to do or not. So basically what we do here, what we have prepared, is to apply statistical econometric technique that very heavily based on conditional convergence approach, and try to simulate regions going from the top to downwards, because it is more stable that rather to disaggregate every variable to the regional level and then to aggregate on once again to region. So rather we have the leading variables that then are disaggregated to the regional level, and then use these leading variables to forecast some other variables, like for instance emissions. So basic structure is like that. So we have the country level model, or we can use or replace this model with external data of any other model. So this is basically the simulation of the model on the country level. And then, so we can have it on the member state level and a member state level. And then in a given member state, we have several regions, yes, some countries more, some other countries less, on NTS2 level, and try to disaggregate basically every variable in the model or every variable in the database to this regional level, if there are data to do this. So we start with GDP as the major leading variable, which looks great on the country level, because you can see conditional convergence in Europe. Europe is basically convergence club, which means that the countries are converging to one steady state, but it doesn't look so great on the regional level. So regions do not converge in Europe, at least in the last 3 decades. Since later, before that, it was also the case that regions were converging, but now this convergence stalls basically, and even on the country level, the regions within the country are not converging, and not mentioning the overall level. However, we take into account this assumption, because probably it is not eternal pattern, because we have observed regional convergence over, let's say, first 40 years or so after the post-war period, after the Second World War. So this is somehow sometimes interpreted as a problem with globalization that impacted Europe and stalled regional convergence in Europe over the last 2 decades or so. So if we take into account the convergence on the European level, then countries will basically converge to the similar GDP per capita in 2050. And if so, it can also be translated to individual countries and then disaggregated to individual regions. So these are examples from, let's say, Hungary and Poland. Later, I will focus only on Poland, but in general, the tool can take into account any European country, at least any large enough to have NTS2 separate from NTS1. And GDP grows, and then you have seen this is GDP per capita, it grows in some regions faster, in some other regions a little bit slower, because we do not observe this convergence, or very large convergence in Poland in this case. And then the 2 variables I want to show with respect to results are energy intensity and emission intensities and emissions. And when you look on the MEVA simulation, but also all the data that have been presented by Fabio, energy consumption falls. Yeah, so over the forecasted 30 years period, but not much. Yeah, so energy intensity is actually shrinking, not because we consume less energy, but rather that the GDP grows. Yes, and this is disaggregated on Polish NTS2 regions. So therefore, this time series is pretty smooth, because basically everything goes in the same direction in the basic simulation, and the data basically show that there is no convergence with energy intensity. This is mostly driven by GDP, and the relations stay very stable, not only in Poland, but actually in every European country and on the European level. So therefore, when you apply the tool, you see that energy intensity does not converge between the regions, but it falls. Yeah, so we consume less and less energy per unit of GDP, consuming basically the stable level per capita. However, when you look on the emissions, then I would like to focus on the different scenario. This is basically net zero scenario. 95% is the scope or the order of reduction in 2050, of emission reduction in 2050. Whereas 75% is basically NDC scenario at the moment, something very similar to NDC scenario in Poland. But what is important, this is something we try to differentiate a little bit the numbers with 2 approaches. One approach is consistent with what was presented by Fabio, namely the disaggregation of IAM to the country level to Polish data, which presents very fast, or even the decarbonization starts in around 2020 and then goes basically with the same pace over the forthcoming decades. Yeah, so decade after decades, it's similar. Whereas the second approach we would like to present is taking into account Polish government approach, at least as it is presented in the official documents up to date, that says that initially in this decade the rate of progress is small, whereas in the next decade and later it is becoming faster and faster, and try to differentiate between those 2 approaches. So it is not so visible when you look on not logarithmic data, but when you look on the logarithmic charts, then you see that this is let's say current trend scenarios, or how it is when the current policy scenario is applied in Poland. So basically this is far from net zero. We see reduction by 50%. This is NDC, Polish NDC. So and the government approach, which basically shows that there's an acceleration of mitigation policies in the 40s. When Poland is forecasted to reduce more and accelerate with its pace of reduction, and especially it is visible when we take into account net zero. Yeah, so then Poland actually delaying the transition as government would want to had to really press the pedal in the 40s and really hurry up with reduction, replacing a lot of sources, and also decarbonize transportation very, very fast. So on regional level, it seems very unlikely, especially that some of the regions in Poland, like this one, are very emission intensive because they are relatively small, and they also have large sources of emissions. So mostly coal plants, but also industry, heavy industry. And so therefore this emission intensity is so high. So it is probably quite unlikely that this type of scenario is feasible. However, when we looked on the numbers directly from IAMs and to try to translate them on the regional level, we see much more coherent picture. I would say that basically this accelerated transition translates itself to the emission intensities that are still linear as they are historically, but a little bit, let's say, more skewed. Yeah, so you have to we reduce simply faster. So it looks, at least for me, much more feasible. Although, of course, the picture is more idealized. But when you look on the historical data, quite likely, so actually every region is doing the same with emission and energy in intensity. So we also looked, and this tool also enables to disaggregate many other variables. So like, for instance, GDP growth. So to individual regions, taking into account the disaggregation of what is happening on the disaggregation, for instance, of energy production in a given region. So here you see comparison of these two scenarios. So the current policy scenario with net zero scenarios. So both scenarios lead to additional GDP growth, the order of 1.5% to the GDP level over these 30 years. Yeah, so GDP is higher in this reduction scenario compared to no reduction scenario. This is the comparison level. So, and in this case, it is higher by almost 2 to 3%, depending on the region. But the differences are dependent on the regions, and the regions that are, let's say, more coal intensive today, like Polish Silesia and generally southern Poland, and have very industry intensive, like for instance here Wielkopolska, and have a lot to reduce. Let's say are less, have this a little bit less positive result compared to these regions that are less industrialized, more service oriented, and have large capacities to install renewables. And basically they benefit from installation of renewable sources. So you see this in the coast, and you see this also in this eastern Poland, which I believe is a good result because it shows that it is also some kind of opportunity for less developed regions, like for instance Eastern Poland. Eastern Poland is less developed than Western Poland. The specific region is Mazowieckie, which is central region with Warsaw, which is pretty rich, but also pretty empty. So very good for renewables resources, and it also benefits. So These are the conclusions. Conclusion basically says that energy consumption will grow a little bit slowly than GDP, improving energy intensity, but in general, this effect is small, and one should rather expect large modal shifts. So, for instance, electricity intensity grows, and it grows on the country and in the regional level in the pretty consistent way, which means that there are not large differences between individual regions, and those differences that can be visible in the data should be attributed to rather to the differences in GDP dynamics than to differences in the transition or composition of the transition on the regional level, which is also partially a reflection of the copper plate of the energy system. So basically everybody consumes the same electricity bundle. And industry differences are not very strong, so which are not affecting this result very much. And however, when you looked on the transformation phase, the delayed transformation looks problematic, hard to implement, and it looks even harder to implement when you look on the regional data, because it shows that in certain regions it should be very, very fast, which I presume is only possible if you imagine that the CCS replaces some sources in those very coal-intensive regions at the very end of the transition period, or some other large replacement happens at the very end of the transition in a given region. When you look on the GDP data, those regions that benefit the most are those regions that can benefit directly from transition towards renewable or nuclear energy, because this is where the new sources of energy appear, whereas the other regions benefit mostly from additional impulse to GDP, which comes from energy savings and fuel savings. Yes, the money are not being spent or importing fuels, which are very consistently distributed among individual regions, so they do not differentiate individual regions. Thank you very much. This is all I wanted to say today.
Okay, thank you very much, Maciej, for a clear regional focus and insights, especially also on the issue of potential of renewables, which I think is also a great link to the next speaker, which is Evelina, who has been working also on subnational modeling on especially low carbon electricity, but also renewables, and yeah, the regional disparities. I'm very happy that you will also give us the insights, which should be hopefully also be comparable or interesting to contrast with these economic modeling findings. So Evelina, yes, we can see your screen, perfect. So the floor is yours.
Great, thanks Johannes, thanks for organizing this seminar. So indeed, I will present some of the work that we did on the electricity sector of Europe with a focus on regional inequalities. And so this is mostly the work that was done by Jan-Philipp Sase, who is the main author of this work. So as a starting point, we all know that we work in the same context of the European Green Deal and climate neutrality target, and that of course needs quite a large change in the electricity sector, which is the first sector to decarbonize and deploy renewables. But it's also important to know that the European Green Deal explicitly, emphasizes this the need for equitable transition. So in the original document of the 2018 vision, it says, it's about the transition that leaves no region and no person behind. And yet, if we look, for example, how so far renewables have grown, so solar and PV in Europe, or which capacities have closed, we already see quite lots of that there's quite lots of spatial differences between the regions. So basically, that is something that we looked at, but in a, of course, prospective sense to the year 2035. And our aim was to estimate the multidimensional regional benefits, vulnerabilities, and related inequalities of implementing electricity targets in Europe. And here, as a policy target, we chose of at least 70% reduction in greenhouse gas emissions in the electricity sector, which in principle would be then consistent with, so by 2050 would be consistent with the net zero whole energy system target, so whole system target. And our resolution is 296 regions, not only in the European Union, but we also have, for example, some more countries in the Balkans, Switzerland, of course, UK, Norway, and so on. And in terms of the methods, we use this expanse model that we have in the group, which optimizes the electricity generation, storage, and transmission. And below, you see the key technologies that we represent. So we also have batteries and hydrogen storage and so on. And it's a single year model, but at the same time, we both optimize an operation, but also the installed capacity mix. And we have optimized, how to say, we know that 6-hour time resolution is the optimal compromise between the accuracy of the results and the computing time. And basically in the study that I will show, so it is an optimization-based model. So that's why, first of all, we run a minimum system cost scenario. So that is the benchmark of least cost scenario. But we also have something that we call frozen scenario of the current system. So it's the kind of scenario for 2035 that would basically keep the electricity installed capacities of today. But, you know, build any, if the demand changes, it would can build additional capacities or operate them differently, but still basically the mix of power plants stays of today. And then in our model, we also use something called modeling to generate alternatives, which is a type of uncertainty analysis that allows us to generate. So here you will see almost 250 scenarios that are either cost optimal, like this first scenario, or have up to 20% higher total system costs, meaning that, you know, they may be a little bit more expensive, but at the same time might have very different technology or inequality implications that we are interested in. And we couple all of that with a benefit vulnerability framework. So basically for each of the regions, we estimate investment and divestment, employment, electricity price changes, land use, greenhouse gas emissions, and particulate matter. And of course, there we want to both identify regions that most benefit or either are vulnerable. And for vulnerability, we adapt a concept of vulnerability from basically climate adaptation literature, where we measure that as the adverse impact, so let's say divestment, but also how sensitive is potentially the region to this impact, and to what extent it can adapt. And basically out of that, we create some indices for individual impacts, but also overall. So here, just to show, you know, I said we have these different impacts, and then for sensitivity and adaptive capacity indicators, we use mostly socioeconomic statistics that is available. So if we take, let's say, divestment, so, you know, the regions that are really dependent on, for example, lots of people and income from the electricity sector, of course, to divestment, they are more vulnerable then. Generally, of course, regions that have higher government debt might also have higher sensitivity, and that have low GDP because they are generally poorer. But at the same time, other regions, or the same regions, might also be able to adapt easier, because they have high employment in high-tech sectors where they can, how to say, they can create new jobs, or they are very well connected in terms of logistics, so it's easier for them to develop other kinds of industries, or they have basically the governments of high quality that can deal with such societal challenges. So now, in terms of the results, first of all, I would like to show, so the model is as I showed, disaggregated to these 296 regions. But here now we will have a little bit of the national results. So here you see the technology mixes in terms of installed capacity in 2035 for the frozen generation scenario. So that's, you know, more or less the kind of scenario that we have today, where there's still lots of coal and gas, etc. And that is already this minimum system cost scenario that meets at least 70% emissions reductions. And we already here see basically that significantly reduced role of coal and other fossil fuel technologies, but also lots of wind power. So let's say we now spoke about Poland. So there's lots of wind power and some solar, and yeah, in the south of Europe, more solar electricity, so on. And that's just two scenarios, but we can also look at these, you know, scenarios across these MGA scenarios that we have as a sensitivity analysis. And here you see installed capacity. And if we take with a star here, this frozen generation of scenario that represents basically the continuation of today, we see that there's really two types of technologies, which is wind or solar, that they are major players of basically they increase to meet the emissions target. But at the same time, there's quite lots of flexibility. So they're to some extent a little bit interchangeable between themselves, because they, you know, there are also scenarios with their relatively little rooftop PV, for example, as far as other technologies would be high. And then there's a range of technologies that, you know, don't see that much variation. And then, of course, gas, coal, and things like that, they really basically need to be phased out. So then we can also look at the impacts, where we see also here now we have this, for example, frozen scenario with a star. So what would we see in terms of investment, that for the whole continent, if we don't look at the regional level, there's of course there's large investments that for these different scenarios that need to be mobilized. This also, of course, cuts greenhouse gas emissions. We predefine that. It increases employment, so it's all in green, and decreases particulate matter emissions. So there are core benefits with air pollution mitigation. However, depending on the scenarios, we see that for electricity price, well, we can get different types of scenarios, and generally there's an increase in land use, but that we also expect from renewable technologies. So at the continent level, it all looks good. However, it's more complex than when we get to the regional level. And here, first of all, I will just show you this example again on vulnerability at regional level. So before I mentioned the divestment, so basically which is related with phasing out legacy infrastructures like fossil fuels, and if countries have foreseen that, then also nuclear power. And we would see that, so basically this divestment impact, of course, it's highly variable in Europe. So darker areas have higher divestment here. But then there's also this sensitivity of regions that I showed we define with some socio-economic statistics. It's actually a little bit higher in some regions, especially in southern Europe. And yet there's also some regions that can adapt a little bit easier because of this criteria that I mentioned. And we can basically do this analysis, you know, impact by impact, region by region, and so on. And then just in the sake of time to show some main results. So eventually we created all into a composite index. On the one hand is the composite index of benefits. And here what you can see that actually across these 250 scenarios, there are regions, especially in the northern part of Europe, that actually tend to have higher benefits. So it's more neutral, let's say, in Central Europe. There's some benefits also, you know, in Spain and here. But especially it's very visible that in Northern Europe, the benefits are more concentrated. Yet when we look at the vulnerabilities, we see that also the increased vulnerabilities, especially in the southern and southeastern Europe, which in a way a little bit shows that, you know, when we are looking at these scenarios to mitigate emissions in the electricity sector, there's actually a risk of reinforcing some of even these regional inequalities that already exist today, basically between south and north and a little bit west and east, because some, you know, some regions they are particularly vulnerable. So basically, in terms of the key findings, so we found that this 2035 target for Europe leads to continent-wide benefits rather than adverse impacts. But these continent-wide benefits hide some of these regional inequalities that might be sustained with the energy transition. And especially where we see that benefits risk to continue being more concentrated towards the north, and more the vulnerabilities towards the southern and southeastern Europe. And basically, this is just a glimpse of the study. It's of course a longer study. So if you are interested, it's already published and available in Nature Communications, where there's also detailed data for each impact, for example, and uncertainty analysis and so on. And that's it from my side. And yeah, happy to answer any questions.
Great. Thanks a lot, Evelina, also for keeping the time well. Great. So I think we had 3 really spot-on presentations on national, global scenarios, how to go to a national level, the subnational level, the role of renewables, gains and losses, and the distributional and equal implications. I think really great and leading cutting-edge research on these important implications. And luckily we have time, 50 minutes or so for discussions, question and answer. So please, everyone out there, you feel free to or write a question in the chat or raise your hand, and I can also give you the microphone if you wish to ask your question verbally to any of the 3 speakers. Yes, so we have some time. Please think about. I think the 3 presentations really speak a lot to each other in the sense that some results are very similar, some are also different, given that they look at different things. So I think it's really exciting, and let's start with some questions. Maybe Maciej, I think you were first. Let me try to, yes, I don't know if you can unmute yourself. Maybe Mark, if you could type your question, that could be helpful, because I'm seeming to have a little problem to do that. Sorry for the technical issue.
I think it will be a question for me, he says, and yeah.
Okay. Oh, it's also in the Q&A. Yes. Yeah, sorry. I mean, I think the technical issue helped to solve it. In the meantime, you can type it there. There's also a question by Olavale. Maybe also, in case you can type it while I try to sort out the
all right, so Mark is asking if it's possible to have in the objective function the sole regional criteria. So I guess you probably mean kind of not only the regional criteria, but the criteria of regional equality. So to somehow maximize the equality, you know. So in the way we measure equality, we use Gini index, which actually makes, you know, it all a non-linear function. So basically optimization becomes trickier, but then, you know, one could use alternative definitions of inequality. And I think there, you know, as far, you know, it's a large model, of course, and then we have high temporal resolution, high spatial resolution. So, you know, if something can be done into linear optimization function, then that could be done. But I think with, you know, the definitions that we use now, we have to rather run many scenarios, assess them after that, and then basically we can sort them by inequality.
No, that's I think I can speak right now.
Yes.
Yeah, now
So
we can hear
thank
you.
you. No, okay. My question was, okay, you run the model in a least cost optimization way, and you end up to some regional equality by regions. So I understand my question as, can we limit or reduce this vulnerability in the objective function? I mean, adding a new objective that we reduce, or that we reduce the loss for some region and so on.
Yeah, so something like that indeed, as far, you know, as it's, we could make it into a linear function. I think it could be done indeed and could be interesting because, you know, of course, what we did now, we show also that, you know, we go systematically across 250 scenarios, and then we show what, you know, some of them are basically more equal than others. But of course, the next question is, how can we, you know, maximize this equality? And there's also a question of policies, for example. So this more instrumental part we have not yet looked at, and indeed what you propose could be one of the ways.
Okay, thank you.
Hello.
Yes.
Hello.
Yes, we can hear you.
You can hear me. Good afternoon.
Yeah.
I want to start by saying I appreciate the three presenters. Their presentation is quite unique, and the topic of discussion quite clear, simple, and quite good in presentation. Now, in the light of the three model discourse and the presentation, and our main focus is downscaling carbon emission. Now, my question is, at the local level, national and regional, as well as international level, how can we best adapt this in the secondary school system to ensure maximizing emission of carbon dioxide? Hello?
Yes, I can hear you. Sorry, I mean, could you rephrase your question? Maybe I wasn't sure what carbon emissions you refer to.
In the light of the three presentations, the main focus is downscaling emission of carbon. Now, considering that at the local level, the national level, the regional level, to project the interests of the international community by way of synergy, collaboration, how best can we adapt the model to the understanding of the secondary school learners?
Maybe I can start if
I'm coming. It's like I'm coming from the ESD, that is Education for Sustainable Development Perception. You know, we need to catch the learners young to ensure bringing about attitudinal change, both at local level, at national level, at regional level, to project actualization of the international community, which is global. So in the light of that, how can we best adapt this model to the understanding of the secondary school learners?
Yeah, perhaps I could start, and the others maybe will want to add. So in our model, you know, so actually the only thing we set top down is this, you know, European target of emission reductions. And actually for the rest is the model that estimates where would be the cost optimal or near optimal regions to mitigate, and which power plants to close and which power plants to build and so on. And I think here it's actually that so basically, it's not that we just downscale somehow the European target. We really, the regions, they optimize themselves, but what they do. And yet I find that these actually already, the three presentations, we are all on, how to say,
interrelated, yes. There's synergy in the three presentations, no doubt about that.
But exactly, and then because that we present also this regional data, because I think for what you told about the attitudes, right? I think it looks all quite different if one speaks about, 70% emissions reduction of electricity sector in Europe, or then in my specific region, and if it's this region is a coal region in Germany or Poland, or it's another region somewhere else. So I think that's already there. We are quite, we are better able to probably link to any of these more local attitudes.
But then, permit me to say this, I quite understand the presentation in question, but then, mitigating, let me use that word, mitigating the effect of carbon emission, there is need for global synergy. So your presentation, yes, you have used European, what have you, as case study. I quite understand. But then you also agree with me. The essence of my question is to see how adaptable to African context the presentation of model in use is. Are you with me? And if we are to adapt it within my own jurisdiction, I will have to start from the secondary school level.
Yeah, let me just.
Yes, I can say, probably Fabio can say, because on African countries, in Europe, we have this comfort that we have a lot of data on regional level. So it's much easier to downscale to regions and then to discuss it with the local community, how the transition will affect them. Yes, but I'm not so sure whether it is doable for Africa because of the lack of the data. However, for sure, it is doable on the country level. Yeah, so those countries that are not covered maybe by international models can be represented, downscaled from more broader regions to the country level.
Yeah, correct. And just wanted to say that we have downscale results also for African countries. So if you take a look, for example, at the NGFS Scenario Explorer, you can find a lot of data for also for the African countries. But as Maciej mentioned, we don't have maybe all the countries because for some countries there's lack of data, and therefore we have some difficulties in harmonizing with the observed historical data.
I quite agree with you.
Thank you very much. So I'm sorry, but I have to interrupt it a bit because we're a bit out of time. I'm afraid for that, but I agree the educational aspect is important. Just to give one last big question to Robert Pitzker in case he's online. And there's another question. Yes.
Can you hear me? Thanks. Thanks a lot for the three presentations. Fabio, if I may briefly ask a question, maybe it also applies to the regional downscaling, but on the national one, I'm really always wondering. You probably have to do a lot of like assumptions by hand to make sure in this mid or long-term convergence. I don't know if you have probably 2035, you already start to go quite far away from the current historic data to what the model produces. And then if you have some regions where one country does have a steel sector and the other doesn't, and then you somehow have your industry final energy and you need all the coal you need for the steel making and the other country doesn't have it all. So like how does this actually work and not produce huge problems? Similarly with electricity sector, I mean, nuclear is very chunky. So if you if you go down to countries or even further down to regions like within Poland, if you have some convergence until 2050, suddenly like you have some 100 megawatts standing everywhere, which is quite unlikely. So how do you deal with these issues?
Yeah,
maybe a very short response. Sorry, we're a bit out of time. But
Yeah.
yeah, important question. There's also one in the chat, and you can answer in how it is done on regional level. But
yeah, I'll keep it very short. So basically, yes, there are some differences across the countries, and then especially those differences are even bigger or more noticeable, especially when we look into the small countries. For example, if you look into Malta or those small countries where there's a lot of generation from oil power plants, and then oil is phased out at the regional level because it's a very, it's a minor component on the electricity mix, then you see this effect amplified at the country level. So yes, this is something that can happen when we do the downscaling, but for the next phase of the NGFS project, we are actually making an effort to better harmonize the data with historical data. So in order to minimize also a little bit this effect.
Yes,
okay,
I can
great.
basically confirm that this might be challenging. So, for instance, we do not, at least in this, what I presented in this phase, we didn't projected nuclear energy separate from other, for instance, renewable sources, yes, because of the granularity, yes, and it's going to happen in, let's say, 2 regions or 3 regions or something like that. However, if you bundle it with the others, then this problem disappears, yes, on the regional level, because basically you can have only different proportions which are being led by other variables, like for instance, density, population density, or availability of some resources like water. And then you can disaggregate the electricity production to zero emission sources using this leading variable in more continuous way.
Thanks.
And maybe a very last question, also to the subnational question, a bit related by Summit or in the chat, is about the regional subnational downscaling, because we saw that at the national level we have this cross-national convergence. So the question is also, do you apply a kind of convergence also within regions, which I think what we saw, and how you validate this data? I mean, is there a way to validate the subnational data convergence, for instance, energy density, which...
Well, the problems with subnational convergence is that it depends on the window of the data. If you take long enough window, then it does exist, really. Yeah, so over 100 years, so we have this historical reconstructions of GDP, and then you can see that regional convergence in Europe really takes place and regions converge. But when you look on the 20 years periods, then it doesn't. And then that's the question, should we take it or not? And let's say we take the assumption that it's going to happen, but we of course are very much aware that it may not be the case in the forthcoming 20 years, yes? Or however, because we are after this pause of regional convergence, it seems conditionally likely that it will reappear.
Yeah, good points, and yes, I think very important topic also in the whole equity discussion on decarbonization across regions, countries, but also within countries. Great. That was, I think, a very long, intense, but also to the point presentation on a coherent topic, which is really great to see. Yeah, really, thanks a lot for all joining from all over Europe and even globally, and especially to Maciej, Fabio, and Evelina for being with us and sharing their thoughts and research. And yeah, we'll see you soon for the next CMCC or also Navigate webinar. So yes, please have a nice afternoon, and see you next time. And thanks for your interest. Have a nice day.
Bye.
Bye.